100 goes here. This 20 is divided by 2 and divided by the coefficient in front of the a, which is 1. So 20 divided by 2 divided by 1 is 10. Times 10 is 100. 25 goes here. 20 divided by 2 is 10. Divided by the square root of this term, which is 2, is 5. 5 times 5 is 25. Nine will go here. First we divide 30 by 2, which is 15. We then divide 15 by the square root of 25. 15 divided by the square root of 25, which is 5, is 3. The last step is to square 3. 3 squared is 9. 36 goes here. 12 divided by 2 is 6. Divided by the coefficient in front of the b is just 1. So 6 times 6 is 36. 1 goes here. 2 divided by 2 is 1. 1 squared is 1. 64 goes here because 16 divided by 2 is 8. And 8 squared is 64. The 81 goes here because 18 divided by 2 is 9, and 9 times 9 is 81. So these can now be factored. The first one is a minus 10 squared. The 10 times 10 is 100. The square root of a squared is a. And the minus sign always comes from the one that's before the second term. The next one is x minus 9 squared. The first term x is the square root of this first term. 9 is from the square root of the third term. The sign, this minus sign, comes from the one that's before the second term. Our next one can be factored to a minus 8 squared. A squared, or the square root of a squared, is a. We take this minus sign, place it here, and 64 squared is 8. Our next one is b plus 6 squared. The square root of b squared is b. We place it here. We take this sign, place it inside the brackets, and the square root of 36 is 6. So we get b plus 6 squared. Our next one will be x plus 1 squared. The x is the square root of the first term. The 1 is the square root of the third term, and the plus sign comes from the one before the second term. 2a minus 5 squared comes from the square root of the first term, which is 2a. Then a minus sign comes from the one before the second term. And the 5 comes from the square root of 25. Lastly, 5x plus 3 squared. 5x, is the square root of 25x squared. The plus sign comes from here, and the 3 is the square root of the third term. Completing the square. The process of determining the value to make a trinomial that is a perfect square is referred to as completing the square. Quadratic relations, or parabolas, can be graphed quickly if we know the vertex, direction of opening, and the stretch factor. All of this information can be obtained easily when the equation is written in vertex form. This is vertex form. Here is the perfect square, x minus h squared. The standard form of a quadratic relation can be written into vertex form by using a process called completing the square. Here's a standard form. Here's the vertex form. We need to go from standard form to vertex form. And we do so by completing the square. We're going to rewrite the given equations in vertex form. We're going to start off with standard form and move it to vertex form by completing the square. Here's our first example. Y equals x squared plus 6x plus 4. This is not a perfect square trinomial, but we're going to use one that is close to it. X squared plus 6x plus 9. Notice we've changed the third term. This is our perfect square trinomial, and here's its factored form. X plus 3. So we use the first two terms to figure out what the third term will be for the perfect square trinomial. We're going to use that now back over here. So we're going to take this plus 9 and add it to this equation. But in order to add it without changing the equal sign, we have to then subtract it. So what we've done in effect is added 0. We haven't changed anything about this. We added 9 and then we took 9 away. So we're still left with x squared plus 6x plus 4. We do this so that we can then group things like this. We place brackets around this. Notice that these brackets create a trinomial that is here. So this trinomial is now inside this one. And we still have our minus 9 plus 4. Our next step is to take our factored form of this trinomial and replace it with this standard form. So we'll have x plus 3 squared minus 5. It's minus 5 because negative 9 plus 4 is minus 5. So there we have it. We have our our vertex form. Let's look at another example. Y equals x squared minus 10x plus 32. What is the corresponding trinomial that is a perfect square? Look at these first two terms. The perfect square trinomial that uses these first two terms is this: x squared minus 10x plus 25. When we factor this, we get x minus 5 squared. So, our next step is to add this plus 25. So we put it in here. Here is that trinomial that's here. But we can't just add 25 without taking it away. So in effect, we've added 0. Now we regroup and simplify. Here's our factored form of this trinomial, and negative 25 plus 32 is plus 7. We're going to continue completing the square of some more quadratic equations. Remember, when we're completing the square, the goal is to rewrite the equations in vertex form. Example 3. Y equals 2x squared minus 12x plus 7. Our first step here is to remove a common factor from the first two terms. We're doing this so that we can get just x squared as our first term. So we remove 2, that's x squared minus 6x. Notice we have not done anything to change the value of this equation. All we've done is factored. Working with x squared minus 6x, we'll try to find the corresponding trinomial that's a perfect square. It's this, x squared minus 6x plus 9. We know it's plus 9 because 6 divided by 2 is 3, and 3 squared is 9. And this can be factored into x minus 3 squared. So, we add this plus 9 to the equation, but we can't add it without also taking it away, so we're effectively adding 0. And here we've done that. Our next step is a bit tricky. Notice that we've replaced the brackets. So the negative 9 has moved outside of the brackets. Notice though that when we moved it outside of the brackets, we multiply it by 2. That's because when it was inside the brackets, it was multiplied by the common factor 2. So when we remove it from the brackets, it still must be multiplied by the common factor 2. We then factor our trinomial here to give us x minus 3 squared. Then we have negative 18 plus 7, which is negative 11. So our vertex form for this example is y equals 2 times x minus 3 squared minus 11. We can now check our answer by expanding. So let's try it out. We're expanding here. X minus 3 times x minus 3. So we have 2 times x squared minus 6x plus 9 minus 11. We'll then multiply using the distributive law. So we get 2x squared minus 12x plus 18 minus 11. 18 minus 11 is 7. Notice this trinomial is the same as the one that we previously started with. So we know we've done a good job of completing the square and identifying the vertex form. Let's try another example. Y equals 3x squared minus 6x plus 11. First, we'll remove the common factor from the first two terms. Remove the 3, so we have x squared minus 2x. Now we're going to look at this binomial and complete it by making it a trinomial, and a trinomial that's a perfect square. So we have x squared minus 2x plus 1. We know it's a plus 1 because it's half of the middle term 2x. This is x minus 1 squared when it's factored. So now we're going to add a 1. But if we're going to add it, we also must take it away. This makes sure that we haven't changed the value of this expression. We now have 3 times x squared minus 2x plus 1, and we move the minus 1 outside of the brackets. When we do that, we must also multiply it by the 3, because when it was inside the brackets, it was being multiplied by the 3, the common factor. We then simplify a bit further. We have 3 times x minus 1 squared, which is the factor of this trinomial, minus 3 plus 11. So our vertex form of y equals 3x squared minus 6x plus 11 is y equals 3 times x minus 1 squared plus 8. We'll now check our answer just to make certain that we've done a good job. So y equals 3x minus 1 squared plus 8. We rewrite the square as this. We use FOIL to give us this trinomial. We get 3x squared minus 6x plus 3 plus 8. 3 plus 8 is 11. So our final is y equals 3x squared minus 6x plus 11. Notice that it is the same as the one we began with, so we know we've done a good job.